So number one just says graph the sine of theta. So we're just going to kind of learn what it looks like by doing number one. And probably, I guess, number two as well. So we'll figure out what it looks like just right from the get-go. So this is not only kind of the lesson, it's also a problem.
That's a problem.
No.
You're a problem.
Ooh.
Ooh, snap.
Just kidding.
Don't lie.
Now, Gracie, I'm not kidding. I need to say you're a problem. Okay. So when we go to graph this, the biggest sign can be as 1 and the lowest it can be is -1. So we might want to put our 1 a little bit higher. So maybe 2 up or 4 up or something. Where do we want to put 1 at? Let's see. Okay. The biggest sine and cosine goes up to 1 and the lowest they go is down to -1. So that's why I'm kind of spreading it out a little bit, because it'll be really small if you don't spread it out a little bit.
How wide will it go?
1 and -1. 1 and -1. So if you want to put like your 1 up here at 4 or something, or whatever. Okay, and as far as how long you go, I'm going to put at my second, where 2 would be, I'm going to put 90 degrees or pi over 4. For some reason they love using pi. Do you guys remember that
180.
pi over 4 was like 90 degrees? So, actually,
Pi over 2 would be 90.
yeah, sorry, my bad.
Yeah, that's 45.
Yeah, I was wrong. Pi over 2, and then pi, and then remember 270 was like 3 pi over 2, and then 360 was 2 pi.
Is
Then,
pi the 5?
huh?
Pi.
So I'm counting, like instead of 2 I put pi over 2, instead of 4 I put pi, instead of 6 I put 3 pi over 2, instead of 8 I put, just spread it out a little bit. And then negative direction, it would be the same, just going backwards. I'm not going to mark all these, but just to let you know, this would be like negative pi over 2, negative pi, negative 3/2 pi, and negative 2 pi would be way over here. Okay, sine of 0 degrees is 0. So sine starts at 0, 0. This is number 1. Okay, sine of 90 or sine of pi over 2 is up to 1. So it's at the top right there. Sine of pi is back down, or sine of 180 goes back down to 0 again. And you could plug these in your calculator, like sine of 180, it'll spit out 0. Sine of 270 or sine of 3 pi over 2 is down to -1. And then guess where sine of 2 pi is? Back up to 0. So the graph looks kind of like this. Okay, what about going backwards? Well, where does it look like it's headed? It's headed down to the bottom. And it goes back up to the middle. And it goes back up to the top. And it goes back down to the middle. So over here, it's kind of a same image. That's what sine looks like. Okay, this is called a periodic function, sine and cosine, because they periodically like repeat themselves. how long does it take, how far does it go before it starts repeating itself? Notice at 0 it's going up through the x-axis, and not until 2 pi does it start doing that again. So the period for this function, I don't think they ask us right here, but we'll need it for later. The period for a normal sine or cosine function is 2 pi, or you could say it's 360 degrees. It's how long before it starts repeating itself. No, they don't actually ask us that yet. What they are asking us on number 1 is find the domain. You guys know what the domain was, remember? Yeah, it's the x values. Like how far left and right can it go? Forever? So what am I going to put if it goes forever left and right? All real numbers. What did the range mean? Up and down. How far up and down does it go? Between -1 and 1. How do I write that? -1 less than or equal to the y value, which is less than or equal to positive 1. So you put the y between -1 and 1. Okay, that's all for number 1.
That's all.
Are we good on that one? Okay, I'm gonna help you with number 2 because it's the cosine. I'll make sure we see that once. It's almost identical, it's just a little bit different.
Isn't it closer together?
No. Can't fix it, there we go. Okay. I'm gonna pretty much do my graph the same way. The difference with cosine is that cosine of 0 is 1. So it starts at the top of its graph. Well, if it starts at the top, guess where it goes next? Down to the middle. So at pi over 2, it's in the middle. At pi, it's at the bottom. Then it goes back up to the middle and back up to the top. And there's kind of you can do a mirror image on the left side. So it goes middle, bottom, middle, top. It just kind of alternates. Like a nice smooth hills. Yeah, you don't have to use the same graph. So, you guys know what the period is on this graph? It's at the top right here, and how long before it gets to the top again? 2 pi, so the period is also 2 pi for this one. They didn't really ask that, but what they did ask is what's the domain range. What's the domain for this one? All real numbers. Goes forever to the left and right. What's the range?
-1 is less than or equal to y, which is
Yeah, identical to number 1. Domain and range do not change. Domain goes forever left and right, all real numbers. Range goes down to -1 up to 1. So, good thing to remember, sine starts in the middle, a 0, 0 going up. And cosine starts up, and then it goes down to the middle.
Does tangent start on the bottom?
No, tangent's weird. I don't think not gonna graph it on this one. Tangent looks like this, and it like repeats itself over and over.
Yeah.
Tangent goes like to positive infinity and negative infinity, and it like repeats itself.
What would be like negative? So it kind of looks like.
We're not doing tangent, so don't worry about it.
Sorry, we went off on a tangent.
A pun that actually.
No.
Okay, number 3 is not graphing, so you can use your graph paper or not, whatever. It's number 2. I'm going to use my graph paper. Number 3 is find the amplitude. Okay, the amplitude means how far is the graph going up or down from the middle. So on my cosine and sine functions, how much did the graph go up or down from the middle? 1. It went 1 up and 1 down from the middle. So the amplitude on 1 and 2 is 1. They didn't ask that. On number 3, what is the amplitude? How far is the graph going up from the middle or down?
1.5.
It's going up to 3. Because they're counting by 2s, what's halfway between 2 and 4? 3. So the amplitude is 3. Another way of finding amplitude is you find out how tall the graph is, like from the lowest point to the highest point, and divide by 2. But another way to think about it is just how far is it going up and down from the middle. But it's the same thing as what's half the height of the graph. Okay, anyways, what is the period for number 3? Which means how far does it get before it starts repeating itself? So at 0, 0, at x equals 0, the graph's going up through the middle. How far does it get before it starts going up through the middle?
Pi or negative pi?
No, it's going down through the middle at pi.
2 pi.
2 pi is starting, so just like my number 1. So it's basically a sine function that's taller. But the period is 2 pi because it takes 2 pi units over before it starts repeating itself. So the period is 2 pi.
5 and 6 is going to be weird to find that one.
Number 5, what is the amplitude? How high is it going up from the middle? Looks like a 4, doesn't it? So amplitude equals 4. And the period, how high before it starts repeating itself? Well, kind of goes off the graph, but if you look at the top of the hill, ooh, that looks kind of hard to find too. If you look at the top of the hill, that's kind of vague where that's at, isn't it? Let's see, where would be a good place? It's going up.
9? The top of the hill is at 9?
No. Okay. What's between negative pi and negative 2 pi? You could say negative 3 pi over 2, or you could say negative 1.5 pi. That's where it's going up through the graph on the left. You guys follow? See what I'm looking at? Like at negative 1.5 pi, it's going up through the middle, through the graph. So on the right, where is that at going up through the graph? 1.5 pi. So the question is, how far is it from negative 1.5 pi to 1.5 pi?
2 pi.
How far is this from 0? 1.5 pi. How far is this from 0? Altogether, how far is that? 1.5 plus 1.5 is 3 pi. You could think of it as like this minus that. You could do it like that, but anyways, 3 pi is the period.
What's 4 period be pi?
Number 4 is period, yeah.
How would we do this on 6?
Okay, so it's in the valley at negative 2 pi, and then it goes in the valley again at 2 pi. So how far is it from there to there? Okay, A, those are matching. Okay, so on number 7, okay, this is new. Maybe I should teach it and then we'll try it. That's probably the best method. Okay.
Well, we can narrow down which ones are sine and cos.
Here's some, before we try 7, let's look at this. What do you guys think would happen to the graph if I put a 2 factor in front of it? It would go up twice as tall, not fast. It would be twice as tall as it was. So, like on my number 1, instead of going up to 1, it would go up to 2. Instead of going down to -1, it would go down to negative. So it'd be like twice as tall. Okay? That's what happens if you put a 2 in front. Now, what happens if you put a 2 in front of the variable?
Longer.
Okay, actually everything happens twice as fast, so it's called a horizontal, what's the word they use? Compression? No, it's gonna squeeze. It's not a very good technical term. So instead of looking like this, it looks like that. It's been compressed, like everything happens twice as fast. So it just, it goes through the period twice as fast. So if it was like 1/2 instead, it would go half as fast. So it'd be a horizontal stretch. Okay, anyway, this is twice as tall.
So if it goes like to negative.
This is twice as fast. Okay, what if I put a negative out in front of you? What do you think would happen?
Just goes to.
It's a vertical flip. Everything's upside down. Did they put a negative in front of the variable on these? No, they don't. Okay, so we don't have to worry about that. If they put a negative in front of the variable, it would have been a horizontal flip, but they don't do that, so I guess we don't have to worry about it.
To put it in front of like sine.
Yeah, if the negative's in front, the whole graph flips upside down. Everything that was positive y becomes negative y. Everything that was negative y becomes positive y. Okay, so number 7, they put the 2 on the variable. What did I say happens when you put a 2 on the variable? Everything happens twice as fast. So the period should just be pi instead of 2 pi. So which of those graphs has a period of pi? A. Now, if you look at B, it also has a period of pi, but B is a graph of cosine. That's the difference. Because remember, cosine starts at the top. Also, the amplitude is wrong, but A is a graph of sine because it starts in the middle going up. And the period is pi because it starts repeating itself when it gets to pi. So 7 is A. Number 9. Okay. On 9, it's the same thing but with cosine. So it's just a cosine graph with a period of pi. Which one of those matches that? D. Cosine starts at the top of its graph. You see that's happening on D and B. Those are both cosine graphs. But the period on D is just pi, so number 9 is D. Yeah, let's just finish this section and we'll call it good. Or 11 through 16, I mean that section. That should get us on track. Okay, number 11. So it says y equals 4 sine of x. What's that 4 in front of the sign going to do to the graph? What did I say the number in front does? Taller?
Taller.
So instead of the amplitude being 1, it's going to be 4. So they do ask us that, so we're supposed to say a equals 4. And what is the period? Okay, because there is no number in front of the x, the period is going to be normal. What was the normal period like on number 1 and 2? 2 pi. Okay, but then it does say graph, doesn't it? Forgot about that. Okay, so 11 is going to be a graph like number 1, but what's the difference?
4 times as tall.
It's going to be 4 times as tall. Now, we can kind of put 4 wherever we want. If you don't label the graph, I'll assume your 4 is just 4 blocks up. So we'll just make it a normal graph here. The easiest way to graph these is always do a quarter of a period in your graph. So I did this on number 1 though, so there's not really any mystery. I'm just going to keep with pi over 2, pi, 3 pi over 2, and 2 pi, just like number 1. Okay, and we're supposed to go down to -4 also, I'll mark that. Where does sine start at?
Middle.
0, 0. And then it goes up, right? So at our first step over, it should be going up to the top. Our next step over, it'll be back down in the middle. See how I'm putting dots to kind of mark my path here? At the third step over, it should be at the bottom. And then it goes back to the middle.
So middle, top, middle, top.
Yeah, it just alternates. Middle, top, middle, bottom. Middle, top, middle, bottom. Cosine does the exact same thing. Just goes up and down, up and down. So back here, since it's going up over here, it must be going down. That's backwards. So put a dot right there. It's back to the middle, to the top, to the middle. Maybe time for one more today. 13. Yeah, I guess so. You guys good on that one?
But for cosine, it's like top, middle, bottom.
Right. Cosine starts at the top, so the next step has to go to the middle. You might not want to do 12 yet until we talk about how to find the period, which we're about to do on number 13. Okay. 13 says y equals, I'm not going to write g of x, y equals sine of 1/3 x. Okay, there's no number in front of the sign, so what do, whoopsie, what's the, what the heck? I killed it somehow. Okay, there's no number in front of the sign, so you guys know what the amplitude is going to be?
2.
Nope. 1. It's like number 1. Remember on 1 and 2 when the graph is just sine and cosine just went up and down 1? The amplitude is not the height, it's how much it goes up and down from the middle. Just like number 1. Since there's no number on the front, basically the number on the front tells you the amplitude. So it's kind of like an indivisible 1 right there. Okay, what's the 1/3 going to do? Everything's going to happen a third as fast
So it's gonna
as
be
normal.
elongated.
So it is gonna be elongated. How do we figure it out? Here's what we do. Basically, you always do 2 pi, like a standard period, divided by the number in front of the variable, in front of the x in this case. What is 2 pi divided by 1/3? Yeah, that's like multiplying by 3 over 1. So it's just gonna be 6 pi. So that's the period. We're supposed to say that. Period equals 6 pi. That's how long the graph's gonna go before it repeats itself.
So number 12, we would divide 4.
So on 12 you do 2 pi divided by 4 to get the period.
half pi?
It's a half a pi. So your graph needs to repeat itself. I don't recommend doing 12 until you looked at this one though. Okay, are we good so far? You ready for the graph?
How long is this going to be?
2 days.
No, this graph, because of its.
Well, you can put 6 pi wherever you want to, that's the thing, right? So I could say the sixth thing is 6 pi. That's not usually how I want to do it though. I usually like to split up in quarters so we can use that trick. So do you guys know what a fourth of 6 is? Like 6 divided by 4? 1.5. So you could call it 3 pi over 2, but I'm just going to call it 1.5 pi. And then what's half of 6? 3 pi. And then what's 3/4 of 6? 4.5. So I'm just increasing by 1.5 because that's going to split it up into quarters. And then lastly, of course, would be 6 pi. This makes the graphing, if you get your numbers right down there, it makes the graphing really easy. The amplitude is 1, so I'm just gonna, just like number 1, I'm gonna put a 1 and -1, maybe a little bit higher so you can see it easier. Okay, and then where does sine start at? Middle, 0, 0 going up. So it's gonna be at top, back to the middle, bottom, back to the middle. Now these are kind of a lot of work, but I will make them worth a lot, so don't skip it. If we get them right, you'll get lots of points.